All right, so good morning, good afternoon, good evening, based on where you're at, and welcome to yet another live session related to DevOps Hackathon. Let me begin by introducing the missions that we are trying to follow with the hackathon. Hackathon is basically a 10 mission project where we have broken down most of the DevOps practices and have started implementing it mission by mission. The first mission, first week, was designing a DevOps solution. The second was to build a foundation on Docker. Third, to start with the continuous integration pipeline. Fourth was to when we learned and implemented Ansible to automate infrastructure and application deployment. The fifth mission last week was when we talked about how do you build a scalable, high available cloud infra. And this week we will take up the mission number 6, where we would automate the similar cloud infra that we built last week using a tool called as Terraform. The next mission would be about building a more advanced version of a continuous integration pipeline, and then learn how to deploy the application with Kubernetes. That would be a container-based deployment, and then also set up an automated deployment using GitOps tool, that is Argo CD. And finally, we would end our missions and the hackathon by setting up observability system, that is the monitoring system. So we are on the week number 6 right now. And we are going to talk about cloud automation with Terraform. Let me fold everything else. And that is the objective of today's live session as well, where I'm going to introduce you to the concepts related to Terraform. What is Terraform? Why you should care about it? And I will demonstrate to you how you could automate a 2-tier infrastructure with web application in the front end and database in the back end, and automate it with Terraform. That is exactly what we are going to look at this week with this live session. I would take questions towards the later part of the session. Also, we have people who are joining from the live stream. So anyone from the Zoom session who are members who are joining, you can ask questions towards the end of the session. We would not be taking right now the session from the live rooms and at this point of time. However, you can always join the membership programs and start with the silver membership, so that you can also have access to the content which is shared here, taught here, as well as the missions, and you should be able to complete it as well. Right now, let's get started with the topic of the week, that is Terraform. And we're going to learn about how do you automate infrastructure with Terraform. Now, let me give you some introductory concepts related to Terraform, why you should need it, and why you care about it and all that. It's one of the tools to build and automate infrastructure and deploy it on cloud and do it on multiple clouds, really. So let's take an example. Let's say you're building a taxi hailing service application, and let's say you want to deploy it on cloud. There's multiple advantage of doing so, and you start building your prototype with maybe fewer services, like the compute service like EC2, database like RDS, and maybe a storage service like S3. And you start with that, you build a prototype, it is successful, you launch a product. And once you launch a product, it becomes successful. So you need to start scaling that. So you introduce additional features like auto scaling, maybe DNS services, CDNs, and whatnot. You get funded. So you expand, start scaling up your infrastructure as well. Maybe containerize it, start deploying it with Kubernetes and related services. And you keep on expanding from there as you grow to different geographies, different regions. Since it's a taxi hailing service app, you may want to go global, in which case you want to deploy your application in different geographies, maybe using different clouds as well. And your infrastructure starts growing with your organization as well. The more it grows, more it becomes complex. You need a tool which will help you do all of these activities, including if you look at your infrastructure evolution, you start building and provisioning your infrastructure on day one, and then it keeps on evolving. So it's always in the flux. You keep on iterating over the infrastructure, you add more services, you scale up the existing one, you keep on updating, and that there's multiple iterations on top of that. And then you introduce a team who is going to work building and managing this infrastructure. So they need to start collaborating as well. And then on top of that, you keep on adding more services, more geographies, more scale, multiple regions, multi-cloud deployments, multi-platform deployments like Kubernetes and cloud, or Kubernetes sitting on cloud. And you also end up deleting some of that infrastructure and so on. So if you look at your infrastructure and how it evolves and what you need to manage, that's when Terraform comes in handy to do all of these activities, including provisioning your infrastructure on day one, to updating it, adding more services, repeating, scaling, taking it to the different clouds, different platforms, even destroying your infrastructure. All of that, Terraform can help you do it for you. Now, how does it work, or what all can Terraform do? Let's look at some of the features of Terraform really. So it will help you provision the infrastructure with variety of different clouds and platforms and services. That's where Terraform's providers come in, right? So these are also some of the key primitives that Terraform comes with. Some of the providers include AWS, Azure, and GCP, and Heroku, which are like software as services or platform as services, infrastructure as service providers. So you have providers, and that's how Terraform integrates with these platforms through this concept of providers. Provider is a code which comes as a library to Terraform. And once you install the provider, you can talk to that particular platform and start automating your infrastructure with it and so on. And it can also, the good thing is Terraform supports different types of providers as well. Not just infrastructure as a service providers. It could also be some software, your DNS software or some other software or a monitoring software, which can also be integrated with Terraform. Now, how do you define your infrastructure as a code and automate it? Is using a language provided by the company or organization who created Terraform, called as HashiCorp. And their language is called as HCL, or HashiCorp, HashiCorp configuration language, which is a declarative, abstracted, idempotent language. Makes it easy for you to define what you want, the state of your infrastructure, and it will basically translate that into the actual infrastructure for you. One of the advantages with Terraform is there's a concept of plan before apply, which means you can actually check the state and what is going to be created and whether it is going to be created or not using the Terraform plan command, which is sort of a unique feature of Terraform if you compare it with something like Ansible, where you can do a dry run and all that, but Terraform power plan is much more powerful. It's going to tell you exactly what's going to change, what properties are going to change before you actually apply that state. It also allows you to collaborate, which is again a unique feature of Terraform, where you have a concept of remote state. There's a state file and we can push it remotely, as in, let's say you are using S3 as a backend for the state management. Your state file is stored in S3. And if you have multiple people who are working on the same code and applying that to the infrastructure, only one person at a time can apply it. So it will help you, collaborate with others, and without creating conflicts and situations where you're running rewriting the state that somebody is changing and vice versa, right? So remote state management is one of the unique features of Terraform. Terraform comes with this library of code called as modules. Of course, you have provisioners and providers rather, and then you have let's say modules which help you truly to leverage the capabilities of infrastructure as a code. So for example, if you want to create a virtual private cloud VPC, instead of writing the code yourself, you can get a module which is available in the Terraform registry, and then just use it, invoke it, and have the entire virtual cloud VPC with multiple subnets, security groups, this, that, be automatically built for you, right? So that's fantastic. And then finally, Terraform can also help you comply with the security best practices. There is a policy library, and it can also, for example, you can implement the CIS benchmark policies, and there's a policy library for it on your systems. So it helps you keep your system compliant as well. So some of these are the key features that Terraform comes with. How does it work is you write the infrastructure using a configuration language, and you install something called as a Terraform core or a TF core. And now TF Core integrates with different cloud platforms, and that's how it has a capability of managing the resources across these different clouds and platforms in the form of providers on one end. On the other end, you write the desired state configuration. And that is then read by the Terraform code to generate something called a state file. State file represents the desired state of your infrastructure, and then it compares it using the Terraform plan. When you run Terraform apply, it does the plan, refreshes the state, gets the actual infrastructure state, compares what should be there, what is there, and based on the diff between the two, it will propose a plan for you. And that plan is something that you can apply in the form of it could be creation, deletion, change, updation of the existing resource, etc. And based on that, when you approve, it will actually bring the state into the same desired state, of your infrastructure. That's what it will achieve with the actual infrastructure as well. And that's what Terraform apply does. And you can also run Terraform destroy to do the opposite, where it will compare what should be there in the state, what is there in the state, what is the actual, and it will delete the actual infrastructure to bring it into the final state of deletion, basically, right? And that's what Terraform destroy helps you do. So there are two commands, Terraform apply, which comes with Terraform plan inherently. I'm going to show you that workflow, and Terraform destroy, which will help you delete the infrastructure that you are trying to delete, basically. And then this is the same application that you've seen in the last week that I built on the cloud with AWS. It's a two-tier application with a PHP frontend and a database backend. And that's what I'm going to build on cloud, AWS that is, but this time in an automated way using Terraform. At least part of this infrastructure, the web front end, I'm going to build using the automation, that is Terraform code. And this part I'm going to create manually. And there's a reason for that as well, because I also want to show you how Terraform can bring in the, the state from an existing resource which exists on the cloud, and make it available as a code as well. So this is what we want to build. A VPC with public and private subnets. That's the prerequisite. We're going to rely on the default VPC for now for this session and for this mission. And then we would build or deploy the application, the front end using the web, database using the RDS as a service. This is with EC2. And this is what I want to bring up using Terraform and talk about various aspects of Terraform, various primitives that Terraform gives you. And what are the concepts that you're going to learn here, as what is the concept of provider to talk to, let's say, an AWS provider in this case. Then resources, that's how you write the state of your infrastructure. For example, an AWS instance, when you want to create an instance with web server, you will use a resource like this, and you define the state of that resource using Terraform. Variables are useful for parameterizing configurations, providing inputs and outputs to Terraform, to and from Terraform. Data sources are useful when you have something which is inside AWS already, let's say a database that you've created manually, but you want to bring that or reference that and get the attributes of that database into your code. You use something called as a data source, look up an existing resource, and then bring it into your code as well. Provisioners are useful. There's a concept of providers, which is to connect to the cloud platforms, which is different. Provisioners are, let's say, this is where you're doing a job of Ansible as well that we did earlier. That Ansible was used to configure, install applications, configure those after the instance was created. The same thing can be done with the provisioner as well here. With let's say you define what kind of provisioner it is, like a file provisioner where you're copying a file or running a script and doing something with it, right? So you can have multiple provisioners as well. And modules is where you can bring in the code, third-party code, and get things done much faster, etc. So we will be exploring some of these concepts, like in this session: providers, variables, resources, data sources, a bit of provisioners, modules. And through this demonstrations, I would show you how to build a two-tier infrastructure using Terraform, on AWS cloud. Now, what do I need in order to get started with this? Let me show you that as well. All right, again, if you have any questions, you can put it on the chat. I'll start answering them and addressing them as and when I get a chance. But first thing first, I need is a Terraform installed. So this is going to be broken down. This week's mission, we are going to break down into 3 tasks. What is the task number one? Task number one is going to be, let's say, mission number 6, right? Mission number 6 is about automating, building cloud infrastructure and automated with Terraform. So I'll break it down into 3 tasks. The first task is when I would have Terraform installed and configured, right? And do some basic configurations, like it needs access to the cloud, so credentials there and stuff like that. The second is where I will actually show you the Terraform workflow. How does Terraform work? The concept related to running validate command and then running a plan or format. After formatting the code, how do you validate it? How do you run the plan? How do you run apply? How do you run delete? What happens when you do that? So that is the Terraform workflow. You will understand that through that process where I'm going to show you by creating a resource that is an EC2 instance. And number 3 is where I would actually build you a 2-tier, web app infra. And that's the step number 3 or a stage number 3, right? Again, if you are a member, a silver member or a gold member, you could get started with these tasks later by watching the live session recording that will be uploaded. That's number 1. Secondly, I've given the 3 tasks as the 3 different lab guides, where first lab guide takes you through setting up Terraform, installing, configuring it, etc. The second one, which would help you get started with automating with Terraform, that workflow that I just explained. The third will help you build a cloud infra, and then you can go through the code. And when you want to dive deeper into it, we have the Terraform bootcamp or a Terraform mastery course, which is also available as part of the our platform and the membership, gold membership specifically, where you can go through each of this step by step. That's when we take a step by step approach and an in-depth approach, because it will take you 3 weeks to go through this entire build-up of the labs and plus more and so on. And that would start with getting started with Terraform, writing resources. So this is like broken down into simple step-by-step learning process. What I'm going to show you is more of a quick dive into stuff. But this is a more of a step-by-step learning where you learn about variables and outputs. First, you write resources, then you learn about variables, then you add provisioners. So one concept at a time. Data sources, that's when you bring in your database. Remote state management, that's when you learn about collaboration, remote state with something like S3. Modules, how do we use it and stuff like that, right? So that's the broken down step-by-step learning, which is available in the form of a Terraform Mastery or a Terraform Bootcamp course. So this might be called as Terraform Mastery shortly. So that's the idea. For you to learn and you can complete. So this is broken down into tasks so that you can simply understand with simple few tasks, understand and automate this 3-tier infrastructure. So that's what I would be demonstrating to you today. So I would begin by showing you the Terraform setup, which I've already done half of that at least. And that's very straightforward. So when you want to install Terraform, for example, you just go and look at the official documentation, because you have different ways of installing Terraform client on different operating system. So that is specific to the operating system that you are using, of course. Right, so Terraform installation part is something that I've already done, where I installed Terraform on Mac using Homebrew. That is the tool I have. And I started using this command. Then I did a brew install, brew update. And at the end of it, I have the latest version of Terraform, I believe, installed. So Terraform-V 1.4.6 should be fairly recent version of Terraform if I look at what version I have here, etc. Right, so that's installation of Terraform actually, which I've already have done. So I see a Terraform installed on Darwin MD64, ARM64. That is the uh, platform that I have. I'm on a Mac M1 chip, so ARM64, that is Darwin is the kernel that comes with my iOS operating system, OS X operating system rather. I have Terraform installed. After I install Terraform, I can check by running Terraform as a utility as well. And I see a bunch of commands that I have here. To use these commands to work with a cloud platform, I need to talk to the cloud platform. And for that, I need some authorization. For that, I need to create a user. How would I do that? Is in AWS, there is something called as IAM, which is the Identity and Access Management Service. This is where I'll have to create a user and a group. I already have that. So I've created a user and added it to a group. I'll show that to you again by deleting the user and the group as well once, so that you get a better idea about how all of this works. So I'm deleting the group, I'm deleting the user. I will create it one more time. And through that, I'll show you the process of how you create a user, because you need authorization. And that is in the form of users and groups for the human users that interact with the cloud platform. So let's say I want to create a user. I go to IAM console, go to the users, start by creating a user, provide a name here. And then I don't need this user to access the console. Console is this web UI. So I'll proceed with the next. I'll say add user to a group. So I'll have to create a group first. And here I have a name for the group called as Terraform. Access would be whatever I'm building right now. Let's say EC2 full access, which is the compute service from AWS. RDS full access also. Yeah. S3 full access, just for the sake of it right now. Right. And then this creates a user group. Yeah. I have, I'm on a user creation page still. I've created the group, selected that group for the user, setting up the user who belongs to this group now. And I'm creating a user. Once I create the user, I need the credentials to be added to Terraform. And one of the ways, there are few ways to do so. So you can see that this user has EC2 access, RDS access, S3 access. Right now, full access. You can be very granular with it. I'm keeping it simple right now and adding the security credentials, which in the form of keys, access keys and secret keys. If I have a combination of both and provide it to the host where Terraform is installed, it would be able to connect to the cloud and provision the resources on that cloud. So I'm choosing that and select command line access here. Say understand, next. Just giving a context as a tag. And this generates keys, key pair. This is my access, this is the secret key. I will download it as a CSV file. And this is what I want to add to my system as a configuration. What configuration? It is there in the lab guide as well. You have to add 2 environment variables. Right, at the end of it, you will see it. 2 environment variables need to be added. And that is the access key and secret key. So it is there in the second task, part of the second task itself. Yeah, this is where I show how to configure the AWS provider, etc. And you have to define this access key ID, secret key ID, etc. And what do I define here is the access key ID is going to be this one. I'll copy that over. And there would be one more variable called as a AWS secret access key. All right, I have it here, so I can still look up. All right. I can also add it permanently by adding it to something like bash rc or something like ZSHRC file or some file like that, where I've defined the credentials. So this is going to help me connect my Terraform CLI to my cloud account when I start automating it using Terraform configurations, etc. Now, what are the commands the workflow involves include Terraform validate, which is what I would use to, let's say, validate my configurations, do the syntax check. There is another command called as format, which is quite useful to beautify and, format, reformat your code automatically, which follows Terraform standard style. That is a useful command as well. And then typically you use plan and apply. When you want to delete, you use destroy. You'll have to begin initializing the configurations. And here I am going to use a particular repository where I am going to keep some code. I already have some code, and it's part of this lab guide as well. You will find that at the end of it, it will ask you to take this repository, create a fork of it, take the repository, create a fork of it, and that is going to be this particular one. This one. And task 2, task 3, right? Task 1 is just installation part, which is done. I'll show you task 2 and task 3. So what I'll do is I'll create a fork of it. I can create or I can just use this as a code. I'm not changing anything right now, so it should be fine. But you could begin by creating a fork of it. I'm just keeping it as is and downloading the code. I think for this exercise, that's all right. And task 2 is where I will go, where I will show you this workflow by creating one resource with Terraform to automate what the whole purpose of using Terraform is to automate something. Let's say we want to create an EC2 instance on the AWS here in one of the regions, let's say the Northern Virginia. So I would have to first configure something called as a provider in order for Terraform to be able to start talking to AWS, right? So that first part is the, let's say, providers. And a provider looks like this, basically. So when you invoke it in the Terraform code and initialize it, the provider comes from somewhere like a registry and the namespace, who created the provider, and the actual name of the provider, like AWS here. And then within using that, you can start writing resources, etc. So I want to add a provider for, let's say, connecting to AWS. Yeah. I'm going to reference my lab guide and the code here while I'm working on it to just go faster. So task 2 is where I am. I'm going to show you all these commands: init, validate, format, plan, apply, destroy. To do what? I'm adding a provider to connect to my AWS account. So this is how I will do it. Terraform required providers. Again, I'll be going faster. So that's why I'm just copying the code, not showing you how to write one from scratch. That I do in the Terraform mastery course, really. That's when you go slower and understand each concept at a time. where we have enough time to do so as well. So this is the required provider configuration. When we're saying AWS, the source comes from the registry, as I just showed you, HashiCorp AWS. You can find these providers and what else is available on the Terraform registry by going to registry.terraform.io. Already is talking about providers, so let me go to the registry first. Here you'll find modules, you will find providers, you will find policy libraries like your security policies and how you apply it, etc. Modules is like resources that you can create very quickly using this reusable code. And providers is how you integrate with the different cloud platforms. And there are tons of providers, and this is where the strength of Terraform comes in. Let's say we want to build infrastructure on cloud AWS, so we use AWS as a provider. This is the one. That's the one. And if I look at the documentation for it, it tells me how to use it by sourcing it. Even if I do not provide the registry name, it is going to assume registry.hashicorp.io or registry.terraform.io. And this is how I invoke a provider, define which region I want to create this resource in, etc. And that's what goes as part of my Terraform code. So I begin writing Terraform code main.tf here. This is the required provider with AWS. This being the source, same source, and a specific version and a path. Right, so that's what I want to start with, initialize with, right? And then I'll also add the instance of it, as in AWS has so many regions, etc. So where do I want to create this with? So I would configure the AWS provider with a specific region. So this is like a default region when I define my resources, etc. And when I run Terraform providers, it's gonna read my existing provider. It doesn't have it installed. There's nothing installed here yet. So I would have to initialize it before I start applying using Terraform init. That's the time when it will download the code from the registry related to this provider, which will give me access to tons of resources that come with that provider. What kind of resources? You can see the resources available with this particular provider. This is the provider. And you can look at the documentation where you will find different types of resources on this side. For example, EC2 related, we have so many, right? Just related to EC2, there are so many. That is the strength of Terraform. It has so many resources to automate anything. For example, AWS instance is one of the resources. When I want to create an instance, that is the EC2 instance, I would use a resource like this, basically, AWS instance, and just provide what I want in the form of my properties of that resource. And there I go. I would have an instance ready, right? That's how simple it would be. Once I have initialized the Terraform provider, I can actually start adding some resources. And in this case, I want to show you by creating an EC2 instance, I have already exported this configuration. So it's already there. I've initialized it. And then I want to launch an instance. So this is a process of launching an instance. I'm not going to do that right now. But if I had to, I would have to go and launch an instance, define the image first. First configuration is an image. Second configuration is instance type. So the type of server, like T2 micro, for example. The key pair, the SSH key pair to connect to that instance. That's the next configuration. And maybe you generate a key pair at that time. Fourth configuration is a security group. So at least 4 configurations like image, instance type, key pair, security groups. Those are the typical configuration that you'll have to provide when you create an instance. That is when you do it manually. How do you automate it with Terraform is by writing a resource like this. If you look at a resource, this is basically a definition of a resource with Terraform using HashiCorp configuration language. We write a resource, say that type of a resource and the name. Name is the actual name of the EC2 instance. Type is going to be like something like AWS instance. The type is what you see here, like a resource, AWS instance. Foo is the name of the instance here. And what are the properties of an instance? You define the image, like the type, security group, key pair. right? Maybe 4 configurations or even less than that. So how would it look like when I have this code be written for a resource, AWS instance? I'm building a front-end web server, and I define the image, the instance type, and just the tags. Not even security group or key pair right now. I will add some of that later. And let me show you by creating a resource that is an AWS instance by writing a code or adding a code, not writing this time, but just adding with the configuration that I need. That is an image, the instance type. And this is available in US East 1. That's the region I've selected right now. And I can add some tags to this instance. And let me show you by applying this code first by running Terraform validate. Validate does the syntax check. If there is no issue, it would say everything is fine. There is another command I'm going to run, that is Terraform format. But initially with just check and show me the def basically. What this is interesting command because a lot of times we don't align everything properly, and we don't follow the best style guide and all that, right? All the time. So we just keep on writing the code. The format, when you apply it without the check and def, you'll actually see it formatting the code. It will make it look prettier. Basically, it will have everything aligned properly and not like this and all that. So it's just following the best style guide. And based on that, it is automatically formatting the Terraform code for you, which it has for me here. And then I would go ahead and I've already validated. So Terraform plan is the significant command, one of the USPs of Terraform, and it tells you what's going to happen, right? So one is it is able to connect to the cloud. That's how it is able to find out the difference between the desired state and the current state. So the current state says there is no instance by this name. Front end, it will get created with these configurations. A lot of this is known after apply because it has to create it first, and we have not defined that configuration. So whatever the configuration is defined, it's here, and it says I plan to add one. That's the plan. So this is the good thing. So before you apply, you can check what's gonna happen with Terraform plan, and only then you can go ahead and say Terraform apply, which will anyways do the plan and show you and ask you for an approval. And only when you say all right, yes or no, will it go and create that resource. In this case, it's creating an instance. And at this time, if I go back to my AWS console, go to the region, which is Northern Virginia, go to EC2, refresh, I should see an instance being launched, which you can see now in a pending state. Right, with the configuration which has been given, and I can provide any additional configuration like security group, any network configuration, VPCs and whatnot, any storage devices, tags are added. I have added some tags, so you see the tags being added. Yeah, and it is in a pending state right now. It is running state right now. Now, once I have this applied, if I try and apply again, it detects the change. There is no change really. It detects the state, refreshes that, compares it with the current state. It says there is no drift, so no need to change anything, right? And that's the idempotent part. Idempotence is when you apply the same command multiple times, it knows when to make a change and what kind of change it is. What kind of change is also important because first time I applied, there was no resource, there was no instance. So it said, I will create one. That's when I said it will create one, add one, right? Now I'll make some changes. And in this case, it's a mutable change, meaning it is a change that you can make on a running instance. So it's not an immutable where it will ask you to delete one. So I'm changing just one tag now, showing you by applying, etc. I'm just now showing you modifying the properties of an existing instance, in which case I'll add a tag called as role. So I go to the same code and just add one more tag right here, called as role. Granted, you can add as many tags as you want. And then if I run apply, it does a plan first, and it tells me that it is intelligent enough to know that this change can be applied. And it says that this is going to be changed, not recreated, not deleted, not created. And this is the intelligence we're talking about that Terraform has, and most of the infrastructure as a code tools have, including Ansible as well. And this is called as idempotence. As in, it knows when to make a change and what kind of change. In this case, it's just going to updating a tag. And when I say yes, it's going to do that immediately. It's modifying this instance, and it's just a tag. So if I go to the tags, refresh, I shall see a new tag by name role with value being front end added to this. That's true. Not every change, though, is mutable, meaning you can't just update it like this in place. Sometimes it is a breaking change, and I want to add a key pair. For that, I have a key pair already created. If not, you'll have to create one. So what I'm going to say is, I don't have a key pair defined for this instance, which is an important configuration. So let me add a key pair. How do I add it? What kind of properties is supported? So you can see the properties here actually. If I want to add a key pair, that is the SSH key pair, I shall see a property by name key name here. So key name is something that I can define. I can define it anywhere in this instance configuration. And let's say I want to add it here. The value would be whatever is available on my account. I can use that. So if I have a key pair by name demo, I can use that, right? I already have one. If not, you'll have to create one and provide the same name, maybe right here. Now this, if I try and apply, it's not a property that you can update on the fly. It's gonna tell me that, hey, for this, you need to replace this instance. So one to add, one to destroy. Why? You see, this is being deleted, new one being added. Why? Because you see that force replacements, right? So key name, if you change the key pair, you can't just change it on the fly. You have to replace the instance, and that's exactly what it's going to do here if I say yes. So it is going to delete it. Right now, there was no key pair configured with that instance because I didn't define any. So there is no SSH key pair that you will see in the configurations here. Yeah, there is typically a SSH configuration or key pair configuration somewhere. Key pair assigned at a launch, it says none, right? Because that's what happened. I didn't provide any. So what is happening is it's terminating. It's waiting for it to be terminated before launching. You can change that behavior. It's just waiting for it to be terminated. Now it is creating. After the instance was terminated, now it is creating a new one. When it creates a new one, it's going to have the configuration that I want, which is in the form of the key pair. So you can see a new one being launched in a pending state right now. And if I look up the configuration, it has the key pair associated, the one I wanted here, right? And that's what is happening here. Now it is creating the instance. And once this is done, the instance will be created, ready. I shall see it. That's what you have to do. So with Terraform, that's what you keep on doing. You change properties. If they are immutable, it will replace. If can be changed, it can do it on the fly. And it will show you every time when you run Terraform apply or when you run Terraform plan, it will tell you exactly what it's going to do. And then similarly, you can do a Terraform destroy. It will again ask you whether to go ahead, delete or not. If you want to just say auto approve, and auto approve goes for apply, for destroy, both. Here I'm saying auto approve as in delete it anyways. And this is going to delete the infrastructure that is my EC2 instance in this case. EC2 instance, this one will be terminated, starting run right now. It will be terminated in a moment time here, right? And that's how Terraform workflow is basically when you start with writing code. You write something like main.pf, you add your resources, you add your configuration as in what resource are you creating, where, with which provider, etc. That's what you define. And then you can go and run validate, format, And then two main commands are plan and apply, right? So plan and apply, and then finally destroy to delete everything. So since you are not creating anything manually here, the good thing is, you can recreate the same state of the infrastructure anytime that you want to do again. Even after, let's say, 4 months, you come back and run the same code, it creates the infrastructure the same way, right? And that's about Terraform here. The way you create, destroy the infrastructure, etc. All right. Any questions so far with the workflow that I've shown you here with Terraform?
Gaurav, this is Uday.
Yes,
Hello.
So this is the
Gaurav, can you hear
workflow
me?
Roland, just give us a minute. I think we'll finish the question from Uday and then come.
So in the main TF files, we have mentioned everything in the providers of modules, and then we are executing the TF, right? So this is the best one, or else we can keep the separate the main TF, and then you can create the file, deploying EC2 instance, VPC, and what other things we require. We can run it, or else, but you should want through all the parameters you mentioned in that main TF. So the best one we can do it in the production time.
So main.tf is where your major code, the main code goes. And in production, you'll typically use modules. So you'll call the modules. I'll show you the code in entirety, maybe. So this is how my, this in itself is kind of a module that you see here. And you're going to have something like this in production, like you have application and you want to build the infrastructure for that 2-tier, 3-tier application on AWS, on Azure, on GCP. You may create the modules like this. This is the one for AWS. And then if I go in here, I can modularize the code a little bit, but you still have a lot of that in main.tf. For example, some resources, I put it in the config.tf. Mainly my configuration resources, which are doing some provisional configuration and stuff. But otherwise, I have most of my code in here, main.tf, where it starts with the provider configuration. The backend is for the state management, where you're collaborating with your peers. And then you call your resources, there's a provider configuration, some data source configuration, and then you call your resources like this. This is where my resource is, like AWS instance. But I'm also invoking a module where my VPC, the entire VPC with 4 subnets, multiple gateways, security group configuration, this, that. So all of that is being invoked this way. So you will have modules which will give you the modularization. But when you deploy it, you will have to write a lot of this code into main.tf. In this case, it's combination of modules, resources, data sources. So you have a security group resource. There is a EC2 instance resource. So you are going to see a lot of this into main.tf as well. Not always like will you have different files for each of the component. That's the style that you will see with Terraform in general. And then
does it mean,
yes,
does it mean you can keep all the modules in the main TF or config TF? That's not an issue.
Modules are installed separately. So when you deploy it, you'll see the modules installed and they've been called in .terraform directory. And there are modules. Yeah. The module code comes in here because modules are pretty large. So that code will come in here. And you're just invoking that module. So you're instantiating the module. And that code, when you're instantiating something, that goes in main.tf. And the actual module code will be somewhere else, which will get downloaded when you run Terraform init, for example.
Right. Okay. And second question about that. So sorry, go ahead.
Hello, Gaurav. Oh, can I go? Or you okay? Oh, yeah, done.
Roland, go ahead. We'll come back to that.
Oh, all right. So the moment where you were creating the instance, right, and you created a key pair using the IAC. So how are you going to download the key pair? From the console, right? From the console, when you create a key pair, immediately it downloads right there. You just save it on your local machine. But if you use IAC, how are you going to?
Sure.
Okay.
So let me answer.
Okay.
let me take that question. There are two ways of doing that. One is you generate a key pair here. And what you are referencing is creating a key pair here, like, this, and let's say, and then you say you download it. And
Yeah.
case, I'm assuming when I provided demo as a key pair, I'm assuming that I have done this already. And then I just provide the name. I have a key, private key, which is downloaded on my system. So that's one way.
Yeah.
Second way, and the best possible way is with Terraform. When you're starting to use Terraform, what you would do instead is you will actually have the key pair be generated as well. Let's say, I think it's right here. There's an instance, which is a resource. There is another resource called a security group. There's a key pair resource. So you can generate it and then provide a key name and the actual public key. So what you do in this case is you generate a key pair on your local system. You don't download it. You generate the key pair and you can provide that, or you can have it be created on the AWS side automatically through Terraform. In this case, it's in taking the variables from input variables. Input variables go in here. Input variables are variables.df. So you define the variables like these, like, oh, this is my key pair, which is my string, whose name is Terraform. And is here, so you can define the public key. It will basically, there is a way to create the key pair itself from Terraform. What I would recommend you would do.
Okay. So you make use of your own local machine key pair as a variable using input variable. Then when you did it, okay. So
variables are to make this code a bit modular, but otherwise you could have just provided the name of that public key and whatnot right out of here as well. So you could have done that as well and provided the key pair public key, that entire public key configuration right here. Variables are just to make this code a bit simpler, modular, and data driven.
All right, thank you.
Uday, did I answer your questions, or you still have follow-up question there?
Yeah, you answered for.
All right. Okay. Is there a question from?
Yeah, Gaurav.
Yes, go ahead.
Yeah, the second question about the organization have multiple accounts, right? So the multiple accounts, how do we manage that? For each accounts have different parameters of TF we have to manage, right? So is it we have to restrict it through GitHub, or else we have any other way to maintain in a Terraform?
So you have two things here. One is variables, like input variables, etc. And you can have different variable configurations of the files for different environments and so on as well. That is managed via Git. And the other type of data that you may want to insert is secrets. Secrets can be stored in outside of the actual repository. You can mark it as sensitive data as well. And you can also integrate with something like Terraform Vault to provide the secrets as well. But you have either variables, which can be shared or seen by everyone, and then you have secrets where like a password, which you can provide at the runtime as well. So that's always a differentiation you can make, that it's a sensitive data. And I think there is an example of that somewhere where we have a password number for
Marco
database, and that can be provided through the secret somewhere. It should be there. It'll come there. It'll come. We start using it. Yeah, RDS password. So I can define it as sensitive, which will not be stored. Right. So that's the.
I have another question if you.
Yes, go ahead.
Hi, I'm Red. Is there a way I can shortly share my screen?
No, because I would take further questions later part of it. If you have a question related to the topic that is this in discussion, that is Terraform and the things that I'm explaining, you can quickly ask though.
Yeah, I can mention if you have if I want to create, I already posted the question like creating internal developer platform, basically providing a way for a small.
Rad, because this is a very specific session on Terraform with this mission where we are learning how to automate with Terraform. So if you have a question beyond this, we are open to do that on Thursdays, but not during the hackathon session. So this is a very focused session on Terraform today.
Okay.
All right. All right, so what I want to demonstrate, and the next thing that I want to show you here is how do we build a two-tier infrastructure with Terraform? And I'm going to do it in a certain way because I want to talk about certain topics. And it's the same application that I demonstrated to you how you would build it on AWS Cloud, the web frontend and the database backend. But we'll do it in a certain way, that is the database will be created manually. I'll tell you the reason why also, because what I also want to show you is one of the unique features of Terraform is you can look up a resource which is available in on a cloud or with a provider and use that and get certain references of that resource, like some properties on that resource. For example, when you create a database, the database admin username, the actual DB name, the actual the connection string or a host name for the database and so on. You can get that by looking up the Terraform. And that's a very unique feature of Terraform, I would say. So I'm going to show you by creating a database first, where I'm creating the MariaDB, same way I did last time as well. And even though it is possible to create this with Terraform itself, I'm taking the same this approach where we're doing a manual configuration of database because of that database lookup, data source lookup, as we call it in Terraform. And I'm going to quickly create the database. So with the username, master password. So this password will be marked as sensitive data. Instance configuration, storage, none. I have to provide the security group for the database, of course. So I'll choose to create a new one. And then finally, additional configuration, I'll have DevOps DB as the name of the DB. So I'm just going to recap the configuration. I'm creating a standard create configuration, choosing MariaDB, which is fully MySQL compliant. Choosing free tier, we want to stick to the free tier. DB instance is a server name, DevOps demo will it start with. Username is this, password is going to be, say, admin. The user password is going to be this. T3 micro data selected because of the free tier. And then we want to have security group, which is here. And database options like the initial DB name is DevOps DB. That's what my web server will configure it to have. And I'm just going ahead creating the database. After that, I'll also make sure the security group for the database is configured properly. This is coming up. It has created a security group. I will configure that. I'm clicking on the security group. That is what is going to allow the web server to connect to the database. So I have inbound rules, which I will edit and add a rule to allow anyone within the VPC. It's within the VPC. So right now I'm keeping it this way. Not ideal always. Typically you have a security group name for a database or a web server and so on. That's the most ideal option. But I'm keeping it simple, allowing my web server to connect to a database. And I have that configuration available. Right, and that's my DB configuration. The web server configuration, I'm going to walk you through that. It's already there. The code is already there. That's my task 3. So the code is given, right? How do you write this code? If you want to dive deeper into it, that's what the Terraform Mastery course is all about. So I'll show you the code though here, where we have a provider, which is AWS. Now within AWS, I can choose which region. By the way, I have to choose the right region here. That reminds me of, I'll have to create it one more time, because this time my code will get executed in a specific region, that is Singapore. So I can't have a database in a different VPC or a different region. We're going to repeat this same process in a different region. So I'm switching the region to Singapore because that's where my rest of the infrastructure will come up. All right, same thing here, very quickly. Nothing changes with instance configuration, neither the storage. Connectivity wise, I just select the security group and choose to create a new one called as database. Additional configuration is at two places, this and this. This is where we go and add DevOps DB. Go ahead, create it. And then I'll walk you through the code, which is going to create the rest of the things like key pairs, the EC2 instances, security group for the web server and whatnot. Right. So that's where we have, let's say, the provider configured as AWS. Yeah. AWS also has some configuration. You can define how many regions you want to support, etc. So I'm defining two different regions here, US East, which is Virginia. I'm code naming it as Virginia. This is Singapore, which is Southeast 1. So when I want to create an instance in or resource in this region, I would provide provider configuration like this in every single resource here. You see, everywhere I'm going to start defining provider as AWS Singapore that represents this particular region configuration. And what am I creating? First of all, I'm also looking up the resource. As I told you, you can look up something which is not present or managed by Terraform and have it be referenced from within your Terraform code as well, which is something which is kind of unique feature of Terraform. Don't think this is available in Ansible and so on either. And that's called as data sources configuration. So you have Terraform managed infrastructure, and you have something outside of that. For example, a database, maybe the images, AMIs, etc. You can also look up AMIs, automatically have it added to your code. That is to define which image to start this with. In this case, we'll use RDS as a data source. So I'm defining that as a data source, which will look up that particular data source like this. And then this is for an instance image. Image is looked up using a data source like this. And then I have a filter. So you can actually have a filter for images and say, oh, what is available, what this with that tag, this tag, whatever. And it will take the latest version of your image and use it in your data source as well. In this case, we are just referencing the database and use it in the code using this kind of a configuration, where we say data, AWS DB instance is the data source. You can find this documentation here as well. So the same provider that gives you the resources, the AWS provider, also gives you the data sources. So what is a data source? Data source is, one of the data sources is EC RDS here. Right, and RDS has these data sources. So DB instance, the AWS DB instance, you can look up the AWS instance, and what properties of that can you look up? That is given here: the address, allocated storage, this, that, DB name, DB subnet group, DB engine, endpoints. So all of this, username and secret and stuff like that. And that is what we are referencing in the code that I'm walking you through here. So where are we referencing all of this? I'll show you. So this is the one which is going to create an instance. You can see this looks up an image. Everything is parameterized using variables. So you define the variables, input variables, their output variables. And then you also have some implicit dependencies. For example, when you say, I want to use this key pair that you have here as well, key name, etc. So there is automatic dependency setup between the key pair and the instance. Instance will be created only after the key pair is. Same with security group configuration. You can define the ingress rule, egress rule for the security groups, codify everything. And that's what is happening here. So it's creating instance along with key pair security group, looks up the database, adds it in the configuration somewhere. So you have input variables, which is variables.tf, where you can define, oh, what is the name of the database? How many instances should it be creating? So you can define that as well as a number, by the way. You can define which image, the instance type. So everything that you're feeding in to your code, you can parameterize it this way. Even the key pair configurations and the public key, etc., which is what I'm going to add to this. All of that can be parameterized. Similarly, there are output variables as well, which are then shown as output when you run this code. Also can be used. This itself is a module. So if someone else uses your module, what are the values they can fetch is defined in the output variables. So that's the output. You can, push the code to different, there's something called as provisioners. So provisioners help you run some script. In this case, it's going to run some script onto my system to apply the configurations, add some templates. So you can define templates. In this case, the configuration file, the actual configuration will plug in here. And this will be added as a config.ini somewhere. As part of my code, it does that. So this is called as a template, so TPL file. So this will be replaced with the actual values, which are then taken from the variable, from the data sources, etc. And then the actual configuration will appear on the web server with whatever else it has to have. Now, how do I apply this code is what you will learn as part of the task number 3. Not write it, but more of how to apply it, right? And how do I get started with that is creating a database, which I've done already. And after I create the database and set up the security configurations, then it is simple, where I'll have to first create some key pair. I've already cloned that code in the form of task 3 here, directory. Yeah, it is here. That's where the code is. I'll have to just provide a few things. One is a key pair. There was a question on SSH keys, right? So I have to generate a key pair like this. What this will do, and you have to do it from the same path that is given here, task 3. So what this is going to do is it generates a key pair, which is a private key. And then there is a public key. So what you have to do is take the public key content and add it to your variables.tf, where there is a key configuration, key pair, key name, right? There's a key pair name called as Terraform. And the actual key pair, which is the content of the public key file, go in here. Right? So for this key pair called as Terraform, the actual public key will be imported using this. This is how you import the public keys on AWS as well. So even if you go to AWS directly, last time I showed you by creating a key using the console, the web console, but you can always go here and say import key pair. And what do you import is nothing but a public key, right? So public key and with the name something. And this is exactly what I'm going to do programmatically. Instead of doing it this way, I will do it programmatically, where I'll provide the content of my public key, which is actually this, the entire thing. I provide that as a content. Yeah, it gets imported. It does, right? So that's what I was trying to do. Let me delete. So it will create everything. So key pair, security group, even if I want to create VPCs, it can. It has the capability of doing so programmatically. And that comes as part of the Terraform bootcamp at some point of time. So you begin by first, when you apply, you have to add the key pair, public key, generate a key pair, add the public key to this configuration. And I think that's pretty much it. So it will connect to your AWS account using the configuration provided earlier. So I've just done this. And then I can begin applying. Since it's a new directory, new path, right? Task 3, it doesn't have the .terraform directory, etc. So I have to initialize it. You'll see in what happens now. When I initialize it, it installs all the dependencies it needs, including the provider, which is AWS. There are other resources I'm referencing called as null resource and stuff. And for that, it's downloading the right relevant code as well. And once that is done, it's just a matter of running Terraform validate, plan, and apply, which will have everything configured, really. Terraform validate shows me that should look good, yes. Configuration is valid, Terraform plan. You'll see how many things it's gonna ask now. One is it's asked for a database password, what that I've marked as sensitive data. So it doesn't store it in the GitHub. And then it's going to create 5 resources. What are those resources? It shows me all of these here. There will be a front instance, right? I have provided instances an array. I can create multiples of those actually, if I want to. It will create a key pair, security group. It will also create a couple more resources to apply my configurations like database schema and the actual configuration, which will connect my web server to a database. So all of that is being configured through Terraform. And it shows me everything related to my data source also, right? So you see data source, which is my database. It has looked up the database and it shows me the database endpoint, the user username, the actual DB, what is a database engine. So you can fetch a lot of this information using Terraform. You have Terraform state file as well that gets created once I create a resource here. When I apply, it will create it. And it's going to show me all the data sources and all that. And of course, it would have everything configured. So here I don't have to log in to the server, don't have to worry about that server, where it is, how it is configured and all that. It's going to create everything for me. And I should be able to just see it in action right from here once the instance is created. I'm going to switch to the region where it is happening, which is Singapore region. And you can see it is creating the instance. It will be available. I will copy the IP address. If I just click from here, it won't work. That opens up HTTPS. But if I use the IP address and use HTTP with it, eventually, once it is all ready, I'm going to see my application all working. The state is it's coming up. It's using this key pair. So I will connect. There's a file provision error. I'll try this one more time. Yeah, the first time it executes, I see it has created the instance. It has created the, try to apply the configuration. There seems to be some issue while applying it. I'm going to apply it one more time.
Hey, Gaurav, sorry to interrupt you. So this is the right time to ask the question about, do we need to maintain the versioning for when you want to roll back?
You can do that through the code. Since it is a code which is then revision controlled via Git, you can always do that. So you're going to keep track of this code and version. It's about keeping it a track of it from GitHub. Right. So if you want to go back, you can destroy and apply that specific revision, and that would give you the state from that revision of the code.
Oh, yeah. Right. Yeah, got it. And the second thing about is it the best way to keep all the parameters in a single file to deploy instances and DBs and everything? So, or else do you want to segregate instances in one configuration, other one is in a different configuration file? So, what would be the standard?
So you have a lot of this modular code in the form of when you invoke the modules like VPC is a module, RDS would be a module, and so on. There you have each module has its own parameters like inputs and outputs and so on. When you are building your own infrastructure with it and stitching it together for maybe one specific project, you are going to create a module for that project, which is going to look like this, where you'll have a lot of resources, a lot of input variables, a lot of output variables. And this is the standard practice. You can see this as being used in most of the projects, including larger projects as well. You can add many files and split it, but this is what you would typically see for a particular cloud, particular provider. You are going to have a module of that application. For example, in this case, this DevOps demo app. If I have to automate that, my Terraform code evolves like this, where I may have 3 different directories for 3 different cloud providers where I'm automating the same thing. But within that, anything related to this application, a database, EC2 instance, any other instances, any other applications, services, I'll pretty much have it as part of this main.tf. You can split it into, as I told you, more than main.tf, but you'll find this code either here or some path in this directory where you'll have, otherwise you'll end up creating too many files. If not, let's say one variables file, one output file, it'll be multiple files. It will do the same thing though. When you apply the Terraform code, it's going to show you all those outputs and consolidate all the inputs in one place anyways. So this is the way I have seen Terraform code being written, but you can make slight modifications to it and have more files than less if you prefer so.
All right. So why I ask this question, if you define all the parameters in the main tier, the specific parameters, the last bit, for example, if your DB parameters are configuring, then we have to execute from the scratch. Again, we have to start from that, right?
No, you have to, so when you invoke the code, it's going to call all the .tf files anyways. You put it in main.tf, you put it in x.tf or y.tf, all of that is going to get executed. Whatever the .tf file is in this directory gets executed anyways. So you're not selectively applying the configuration. You can do so by using Terraform commands, but by default, it's going to apply everything.
Cool. Thanks, Carl.
Sure. All right. So the question from Brad is, do you have this code online? Yes, it is there. So as I mentioned at the beginning of the session, you will see it as part of our Ultimate DevOps Bootcamp. You will have this available as mission part 6, mission number 6, where each of this is a lab guide. So task 1, task 2, task 3 takes you through the complete step-by-step execution of what I demonstrated. And if you go to the task 1, at the end of it, you have access to the repository where I downloaded this code from. And it's the same repository, this one, that you can do so from as well. So this is where the code is. And that's why I have this code, so that you can examine it and you can actually apply and see how it would actually work, right? I'm going to try and apply this one more time. I see some issue where it's not doing the right configuration for some reason, or it's going to take some time. Yeah, it's done now. The reason why it was not working earlier is because it has copied script and it was running a script which expected to have certain paths, etc., which was not, which wasn't the case earlier. And since that's been taken care of, it applies it. So if you keep on applying multiple times as well, eventually once the prerequisites have been met, it's going to go and do its job. And at this point of time, I'm expecting this to show me the application, the web front end for this application. That is, if I go to HTTP, not HTTPS, but HTTP in this product URL. Copy that one more time. Just the IP address, HTTP:/. I will also check this from the console here. Terraform AP is my key. Ubuntu is the username. This is the IP address. What it's supposed to do is start a service, Apache web server, and it's serving out of this var HTML. It has some PHP code along with the config.ini. What I expected to have is the config.ini with the correct configurations like this. And this has all been plugged in by Terraform using the template. So it picked up the data source, pulled the configuration like database server address, the username, password, DB name, DevOps DB. It has applied certain schema. And at this time, I expect it to show me the application. It does here. And seems like there was a DB connection error. This should have already taken care of because when I go here and try to run my SQL -u admin maybe with the password, will connect to the host, which is this, maybe this DB. This is expected to work actually. If this is not working, of course, there might be an issue that I have to figure out. And it looks like there is some where the database, I think I didn't update the configuration for this DB server. I did it in a different region, not here. So if I allow the web server to connect, which I should be able to validate from here. Yeah, then this should also work. If I refresh, the connection string does work. I have to apply the schema again. It happens through Terraform as well. It's part of the Terraform's provisioner code, as it is called, where it is supposed to apply the configuration and schema and so on, and then create a table here, which will happen. So if I reapply it once, and have it run the actual script, it is gonna basically show up here, and this should go away. But you can see at least the web server has come up, and it's been configured with the Terraform, the right configuration, and it is able to connect to the database server. And that's what I have done with Terraform, which I can also remove by saying Terraform destroy, and this will delete the infrastructure which is being created here, and that would include what else? So apart from the instance, the key pair. So you will see key pair added by name Terraform. You will see a security group added by name frontend, all via Terraform. And when I destroy it, it's going to also clean up those components, not the database. Database will still have to delete because I created manually. And I'm going to start that process now. But everything else should be gone. So I'm deleting the database now from here. No snapshots, no backups. So just a test. That's gone, but everything else created by Terraform should have been deleted as well, or should be on its way to be gone. Yes, it destroyed everything, including the instance, key pair, security group, etc. So this security group should have been gone by now. This key pair should have been gone. The instance should have been terminated. It'll get deleted, cleaned up from here after some time, but be gone. Just have to delete the security group for the database, of course. When it is done, the database is done, it will show me an option to do so as well. But this is how you can build the code with Terraform, which you can explore. It's available in this repository right here, and you can explore this. So there are many other things which we don't talk about right now, like remote state management, the actual provisioners, the in-depth understanding of data sources, for example, variables, inputs and outputs. And that's what we'll leave for a deep dive with the Terraform Mastery course. But this should help you get an understanding of how you can start automating your infrastructure with Terraform. What are the key primitives? And that would be providers, resources, the variables, data sources. Conceptually, you should be able to understand it, and you should be able to apply the code when you are presented with Terraform and explore further from there. That is the objective of this mission, to get your understanding of how do you start automating cloud with Terraform, basically. All right, any questions?
I will have one. This GitHub repository cannot be accessed. I'm not sure. Is it protected by, or is it private? It's private for the members.
Let me check. It should be a public repository. If it is not, I'll have to make
It is private. There's indication it's private because it's up there.
It's right here. So let's try. I'll compare it with some other repository. This one, for example. All right, this is. Can you access this repository? I'll just.
No.
I've just.
No. It's private. This is written private there, so you need to switch.
I understand that. I understand. I've shared one more repository, and this is public. So just confirming that you're able to access it.
Yeah,
Okay.
I can access.
Sure. So this part is something I'll have to make as public. So I'm just trying to figure out where to do it from.
From settings.
From settings, and
You go down in the very bottom, I believe.
I think this one changed to public. All right. Providing the authentication, now it is public. Can you just confirm that?
So I have a question regarding those template or INI file that the Terraform can use.
Sure.
So how is that different from variables.tfvars file that is supposed to be an override of?
So template is where the actual values will go in. Like, what do you create a template for? I want to configure copy this configuration to my web server. That's what I showed you here. So when I showed you that web server and the file and the actual configuration, it was generated using this template. So you define the variable. So templates alone templates cannot be used alone. So you have to inject something in the template, and that is the variable. So those variables come from the inputs, input or variables.tf. For example, the RDS password, RDS name, and whatever else you fetch as from a data source and whatnot. That actual variable and the value of that will be injected into the template to generate the final configuration.
At what point? Is it like variables define the types and possible default values? I used to see values.tfvars as something that you store like based on the standard. So how how is that different from, where do you provide real values?
So this is where the real values go in. So RDS password, the actual value is
Usually, that's your convention, but it's unusual to have. This is not easy, not easily seen. What are input parameters? As I said, I use TF bars. So now it's a lot to search.
You can define variables. The question is because you can define variables from different places. These are the defaults. So what you see here are the defaults. You can define variables from how many other places? Let's find out. You can define the variables from defaults, the one I have shown you. You can define it in the environment. You can define it in the tfvars.json or tfvars. This is where you're talking about. You can have auto tfvars. You can also have variable file at the time of running Terraform code as well. And this is the level of precedence. So if you have it in defaults, your default. So if you want to override some, you can add it in tfvars. That's what you mentioned. You can use auto tfvars. You can use a specific file like var or var file option to the CLI when you run Terraform apply as well. So there are so many places, at least these many places where you can define the variables from, and you always start defining the defaults. And where do you add the defaults is the place where you see this being used here, the variables.tf.
Okay. And where do you use this templating? Because you did not mention that as some kind of a. I'm trying to understand how it's
being copied. Template is being copied. So you have provisioners, and we are using a provisioner called as a file provisioner here. In this case, let's say we want to apply this configuration. So this dbconfig is what is being used here. And this is the provisioner. So this is where I'm using template as a function, template file as a function. This is the function which is invoking that config.inr.template, providing these variables are being passed to that template as well. And it will generate this and use this basically. So if you explore this code, you will find the template, being copied to this particular destination here. So this is where we are invoking.
So is it used primarily to define a template that will be used as to output some file on the file system, or it can be used for even providing possibly variables values somehow?
So you mean template?
Yeah. Is it primarily used as the means to template a file that on the file system that needs to be created, or it can be used to provide some settings configuration to other modules or Terraform modules?
Template, the purpose of template is ultimately to generate some sort of a file. It's typically a config file, in this case, var www.html config.ini. So how it should be generated dynamically is where template file as a function comes in. So ultimate goal of a template is typically to create a file on the file system.
Okay, so template file function. This is a Go. Is it sorry? Is it a Go function or no? Like
this is HashiCorp's own language. So
okay, so
like a programming language that you can identify with, but ultimately it's just a templating language that HashiCorp HCL uses.
And while we are here, you mentioned you had 3 cloud providers, in one folder. You said I had Google. So if you would have a GitHub workflow that is a manual one that accepts some parameters, and let's say you don't want your, let's say you have a teams that can just say, I want a small instance. I want some database or that is compliant to MySQL. So maybe in AWS it will be Maria, in Azure it can be MySQL, right? So they don't know about that. They know that they will get something that is compliant and they can work against. So how would you, from a small number of parameters that is kind of generic nature, say, oh, I just want to go into maybe Google in Google Cloud or in Amazon. That's the only distinguish. So how can you repoint the execution to certain cloud provider if you're given some generic set of parameters with a little clue. Oh, I want maybe Google instead of Amazon.
No, with Terraform, you are very specific with the cloud, and you have to use the resources which are specific to the cloud. You can't be completely generic, and that's why I would keep this as 3 different directories. So you can have the application configuration, which is generic, and have this config file which says, oh, you have this as a host name, this is a database user and password and all that. But when you write the code with Terraform, you are going to be very, very specific with that cloud provider and so on. So I'll just show you an example of how when this ports to Azure, what happens.
I know that you can be specific, but you have smaller number of things. These consumers are not interested in how this is written. You are platform engineer. You write things in a specific way, but to provide parameters that is needed by the team, right?
Yes, you have to have different modules. For example, in the module for Terraform module for Azure, you are going to have something like this where you have Azure RM and provider.
That is not my question. I understand that. As a platform engineer, I want to provide an interface to a team that has standard fields. And this can expand to either Google, Azure, Amazon in their own specific ways. I understand that. So, but what would be the mechanism to start running it in a GitHub action and like a manual action to, and then redirect the execution to a particular root module? You know what I mean? So you have some input.
You have to have a wrapper. So on top of that, you'll have to wrapper. So that's why I have 3 different modules here. So you're going to have modules internally. And on top of that, you write a wrapper module. That is another module or another main.tf code where you will invoke it and say, how would you invoke it is, let's say, a user for module called as, each of this is a module. Ultimately, it becomes a module. So you will see that it's not like you have a module which is generic. You have to ultimately call a module like, oh, Terraform VPC, Terraform EC2, Terraform Azure VM, and so on. So you have to be specific with that, but you can just build a wrapper on top of this and say, Terraform VPC, I want to build a VPC. My code in my module will look like this, where I'm invoking VPC module from here and then providing my properties. So these can't be completely like agnostic to the cloud either. So there will be some properties certain cloud requires or not. So it's not going to be very, very generic, absolutely generic with Terraform, I would say.
Like when you see, I send a link to something that seems to be DevOps catalog code with various Terraform modules.
Mm-hmm.
In a link. Do you see my link in the chat?
I see a link, which is this, the final link that you saw sent.
Oh, yeah. So this guy, very well known person in that, he has this collection of all sorts of Terraform modules, and he's big on this platform, like
this code. What you've shared is this code, right? And it has, again, you can see Terraform modules for each of the cloud platforms and so on.
I'm not sure if he has some wrappers around it or just plain catalog, but I know in cross-plane, there is a way to kind of give this little XML or YAML-like structure that defines some kind of small instance. This is small instance. This is some database with some connection string. People don't care. And then I'm trying to find a way whether a Terraform can be like a cross-plane, multi-cloud kind of
if you bring in the code from any such author, we will analyze it and audit it so that you get we can get more clarity on it. So as far as your question is concerned right now, and the code that you mentioned also is you have modules just like I showed you earlier. And you will see that each of this is similar code. So you have main.tf, you have, it's very specific to that platform. And that's how you do things as far as I understand. But if you have seen something where it is done differently, or there is an abstraction on top of this where it is a simplified interface.
So yeah, abstraction. I'm talking about that, how you can start doing that so that you can trigger it from a let's say you can use
absolutely generic is my point. You have to have it very specific to a particular platform, as far as I understand. But if there is a code which does that in a very generic way, I would love to have a look and definitely understand that as well, is what I'm saying. So you can bring in a repository which has that. I'm not aware of one, but if you have any, we can analyze it from any of the authors.
Yeah, I guess I could understand that as an if else, if this module, this variable exists.
That makes no sense. If else statements, etc. in the declarative code, you don't see it in the declarative code. So that's why I'm saying again, if you find it, we'll have a look, and maybe this Thursday, as early as this Thursday as well. With that, I think we'll have to wrap up this session though. And what we are talking about, what we talked about today was about mission number 6, where we are learning to automate cloud infrastructure with Terraform. And we looked at various aspects of it. I demonstrated to you how you can set up Terraform, how you can integrate with AWS Cloud, build an infrastructure on it, and also destroy it using Terraform, right? It's all through the infrastructure as a code. So what is possible with Terraform is what we are taking up. And that's where we stop here. Next week, we will take up another topic where we'll actually enhance our existing continuous integration with container-based delivery, etc. We'll talk about building images, automating that with Docker and things like that, which is going to make it interesting. And then further, we'll deploy it with Kubernetes, automate it with Argo, set up a monitoring system, and we should be done with our larger project with 10 missions. That's our part of our DevOps hackathon. So that's it, folks. So thank you very much. I hope it was useful, and I'm going to see you again next session, next week, of course, with a new mission. But before that, we'll have an inner circle call on Thursday, as usual, 7 p.m. IST, and you're welcome to join it as well. So thank you, and I'll see you in one of the next live sessions. Thank you. Bye.
All right.